Hello class. Today we are going to finish up the lesson on perpendicular bisectors and angle bisectors. Now, in the previous video we talked about the perpendicular bisectors. Now we're going to look at angle bisectors. And again, we have seen these before. We have looked at angle bisectors before. We know that an angle bisector, that is this line right here that cuts the angle in half. So you have two congruent angles on either side of that angle bisector. Now, what we're going to do today, we're going to look specifically at the angle bisector theorem. And what this says, if there's a point on the angle bisector, it is going to be equidistant from the two sides of the angle. Okay. Now, the important thing to remember here is the distance from a point to a line is always going to be this perpendicular segment from the line to the point. Okay, so we're not drawing a line out here, we're not drawing it over this way. It's always got to be perpendicular to the segment. We're not using this line here because it's not perpendicular to the segment. We want this one here, segment BD, because it's perpendicular. That's distance. All right, so what this says is that segment BD is going to be the same length, the same distance as from D to C. So BD is congruent to segment DC. This is the angle bisector theorem. In the previous one we saw the perpendicular bisector theorem. This says, hey, if it's on the perpendicular bisector, then it's equidistant from the endpoints of the segment. This, you'll notice, is very, very similar to that. It says if it's on the angle bisector, it's equidistant from the sides of the angle. Not the endpoints of an angle, because angles don't have endpoints. That wouldn't make sense. But it is equidistant from the sides of the angle. What that means is that these two segments are congruent. It means if I had a point down here, these two segments would be congruent. All right, the distance everywhere on this line is the same distance from this side of the angle as it is from this side of the angle. That's what the angle bisector theorem says. All right. Now, the good thing about this, the converse is also true. Converse says that if a point is the same distance from both sides of an angle, it must be on the angle bisector. So since segment BD is congruent to segment DC, and you'll notice it is perpendicular to the sides, because remember distance has to be perpendicular, since it is perpendicular to the sides of the angle, then ray AD must be the angle bisector, which means angle BAD is congruent to angle DAC. All right, that's the converse of the angle bisector. All right, so let's take a look at this. Open this up. Okay, and here we go. On numbers 5 through 7, find the indicated measure and then explain your reasoning. You have to explain. Because geometry is all about prove it. So here we go. We want to find the measure of CAB. So angle CAB. So we're going to measure this whole thing. Well, it tells us this angle, angle BAD, is 20 degrees. The question is, what is the measure of angle CAD? What can we do? How can we figure this out? Oh no. Well, we have right angles here, which means that BD is the distance from this side of the angle, CD is the distance from this side of the angle, and so D is the same distance from both sides of the angle. So if it's equidistant from both sides of the angle, it is on the angle bisector. So what that means is that ray AD is the angle bisector. We know that because of which one of these theorems? Let's see here. The angle bisector theorem says if it's the, nope. There we go, here we go. If it's equidistant from the sides, then it's on the angle bisector. That is the converse. All right, so we know this because of the converse. Okay, so this is the angle bisector, set ray AD here. So what does that mean? Well, if it's the angle bisector, that means it bisects the angle. So that means that this half of the angle is congruent to that half of the angle. So segment CAD, angle CAD must also be 20 degrees. So we have 20 plus 20 equals 40 degrees. So the measure of angle CAB equals 40 degrees. There it is. Because this is the angle bisector, we know it's the angle bisector because D is the same distance from both sides of the angles. All right? And we could also prove this differently since we've done all of our triangle proofs. I've got a side, I've got a right angle, I've got the hypotenuses are shared. This is HL congruence, hypotenuse leg congruence, so I know these two are congruent because I know my triangles are congruent. So CPCTC proves that these two angles are congruent. So there you go. And that also helps. It proves that the converse of the angle bisector theorem works. There it is, using congruent triangles, which is always nice when you have stuff that you've done before, proves that the new stuff works. You know, don't just take my word for it, prove it. That's what geometry is all about. Okay, let's take a look at segment DC now. So segment DC, we want to know how long is segment DC. Well, let's see here. We know segment BD is 5, but that doesn't tell us what we got here yet. We need the angles, though. Look at the angles. The angles are the same. If the angles are the same, that means this is an angle bisector. And if AD is the angle bisector, then D is the same distance from segment from array AB as it is from array AC. These are perpendicular, which means these are distances, and so these are going to be congruent. So what we're going to do here, we have to explain. This, well, first off, DC is going to equal 5 because these are going to be congruent. But we got to explain, and all we really need to do to explain is say that this is the Angle Bisector Theorem. Since this is the angle bisector, the angles are congruent. We know it's the angle bisector. That means they're the same distance apart. All right? Okay. So that wasn't too bad. Let's take a look at number 7. Last one. Okay, so we need to find the length of segment BD. So BD right there. What do we know? Well, we have congruent angles here, which again means that ray AD is the angle bisector. All right, so ray AD is the angle bisector. Specifically, I guess we should say of angle BAC. And that means that the length of BD is going to equal the length of DC by the Angle Bisector Theorem converse. So that means we can set those equal to each other. But it's not asking me for X, is it? It's asking me for BD, right? So what do? We take 1 and we plug it in for X. So 3 times 1 plus 1. 3 times 1 is 3. 3 plus 1 equals 4. So BD equals 4. All right? And there it is. That is the Angle Bisector Theorem. Not too bad. Pretty easy stuff. Important thing to remember, well, here's the really important thing that people miss all the time. These distances, this segment has to be a right angle. It's got to be perpendicular to the sides because distance is always perpendicular from the point to the segment, to the line that you're looking at. All right? It's got to be perpendicular there. All right? So, if your angles are congruent here, these are going to be congruent too. All right? Your distance is going to be congruent. It's going to be equidistant from both sides of the angle. If it is equidistant from both sides of the angle, then that means it's on the angle bisector, so your angles are going to be congruent. All right? And there it is. So that's perpendicular bisectors, and there is the angle bisectors. And hopefully you found that useful, and I'll see you in the next video.